all about solving radical equations. Here are our suggested steps. All right, we want to get the radical by itself, and then we want to raise each side to a power that matches the index of the radical, solve the equation, and then check each solution because we might have extraneous solutions here. And I'll try to explain how that works graphically as we're going through these. All right, so example 1, the square root of 5x plus 1 equals 4. Our index right here is 2. So what we want to do is raise each side to a power that matches that 2. So we want to square both sides, and we end up with 5x plus 1 equals 16. And now we just have a simple linear equation, right? Meaning that x should equal 3. We have to check though, all right? We have to check. Does x equal 3? In the original, okay? 5 times 3 plus 1, does that equal 4? Square root of 15 plus 1, is that equal to 4? Square root of 16, is that equal to 4? Yes. All right, so we are good. X equals 3. The reason why we have to check for potential extraneous solutions is because this act of squaring, we could take something that's not true and then make it appear to be true, right? What if this said 5x plus 1 equals negative 4? What if that were our original, right? We know that the square root of any number is going to end up being positive. So we know logically there shouldn't be a solution here that's real, but when we square both sides, it ends up looking like the rest of this. So we have to always check and see, are our solutions valid? Do they work? Okay, example 2, we want to isolate the radical. Okay, so we want to take 5x plus 3, get it by itself, so we want to set it equal to negative 2. And right here, we should have something going off in our minds that says, hey, a radical is equaling a negative number. That's not going to fly. All right, so we're going to square both sides, carry through as if we do. Solve for our value of x, and we end up with 5x equals 1, x equals 1/5. As soon as we check this, though, it's not going to work. Okay, square root of 5 over times 1/5 plus 3 plus 2, is that equal to 0? So this radical square root of 1 plus 3 is 4. Plus 2, is that equal to 0? Is 2 plus 2 equal to 0? No. Okay, so there is no solution. Okay, let's look at a way we can check this. Okay, so the function we were just working with is the square root of 5x plus 3 plus 2, and it was set equal to 0, which really just means we want to know where do these two lines intersect. Okay, where does y equals 0 and y equals square root of 5x plus 3 plus 2, where do those intersect? And look at that, they don't. So it makes perfect sense that there's no solution for number 2. All right, how about for number 3? So our radical is already by itself, and we want to raise it to a power that matches the index. Remember, the index is 2 here. We're going to square this, square both sides. Remember, this is not equal to x squared plus 1. No, 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 no. Okay, this is really x plus 1 times itself. And we need to multiply x times x times 1 times x, 1 times 1. Okay, we end up with x squared plus 2x plus 1. And now we're going to solve this like a quadratic. Okay, so we want to set ourselves equal to 0, add x to both sides, and subtract 5 from both sides. And then now we can solve this quadratic using our quadratic methods, right? Factoring, quadratic formula, or completing the square. Let's try factoring. X plus 4, x minus 1 is what we factor into, and that means that x equals negative 4, x equals 1. We need to check both of those. All right, let's check x equals negative 4. In the original, so the square root of 5 minus 4, is that equal to 4 plus 1? That's our question. We're checking in the original before we squared. Okay, we're checking in the original. So is the square root of 1 equal to 5? That doesn't make any sense. Oh, that's because we're working with a negative 4 here. Let's see. Give me 1 second. Plugged in my number wrong. All right. 5 plus 4, is that equal to negative 4 plus 1? So is the square root of 9 equal to negative 3? It's a key question. No, it's not, okay? The square root of 9 is positive 3. Remember that this is a different question than a number squared equaling 9. These are two different questions, okay? If I'm asking you what's the square root of 9, I only want the positive one. If I'm asking you what squared equals 9, I want positive or negative 3. Okay, they're two different questions. So knowing the difference between those is going to impact whether or not you can effectively check for these extraneous solutions. Okay, so x equals negative 4, that's extraneous. Now let's check x equals 1. All right, square root of 5 minus 1 equals 1 plus 1. Is the square root of 4 equal to 2? Yes. Okay, so x equals 1 is the solution that we want. Let's take a look at these graphs just for fun. All right, we want the square root of 5 minus x. Where is that equal to x plus 1? Where do those two functions intersect? And look at that, it's at the point x equals 1, which is exactly what we got. All right, pause the video, see what you can do with this. All right, hopefully you have recognized that we are going to square both sides. Be super careful, make sure you remember to multiply that right side like a binomial. And we're going to try to solve this like a quadratic. Okay, so we're going to add x squared to both sides. And then when we subtract 1, we end up with plus 0, so there's no constant here. So we're trying to solve this quadratic. Let's factor out our GCF of 2x. And then 2x equals 0, x plus 2 equals 0, meaning x equals 0, x equals negative 2. Now we need to check and see if either of those is extraneous. Let's check x equals 0. Okay, square root of 1 minus 2 times 0 is 0. 0 squared is 0. Is that equal to 0 plus 1? So is the square root of 1 equal to 1? Yes. Okay, so x equals 0 works. Now let's check our other one. X equals negative 2 is the square root of 1 minus 2 times negative 2 minus 4. Be careful with your signs there. Is that equal to negative 2 plus 1? So is the square root of 1 plus 4 minus 4, is that equal to negative 1? No, it's not. Okay, the square root of 1 is positive 1, not negative 1. So negative 2 is extraneous. X equals 0 is our only solution. Let's check their graphs. Where do they intersect? Where does the left side, the square root of our original, square root of 1 minus 2x minus x squared, where does that intersect with x plus 1? And if we look and see, it's at the point x equals 0. There's no other spot that those two graphs intersect. All right. Oh, I'm on the wrong. Here we go. Last one. All right, last one. We already have our radical isolated. Even though there's two radicals, let's still proceed. All right, let's still follow those guidelines. Let's square both sides. All right, and then we should end up with x equals negative 3. Let's check. Does that work? Is the square root of 2 times negative 3 plus 15, is that equal to the square root of negative 3 plus 12? So is the square root of 9 equal to the square root of 9? Last time I checked, yes. X equals negative 3 works. Okay. I'm going to end this video here, and I'll pick up with the final two examples in your notes in the next one.